moving on to part one directly. So I present you Bogdan Dumitriu, who is the business owner of eDelivery in Directorate General for Informatics at the European Commission. So Bogdan, the floor is yours.
Thank you, Ines, and good afternoon, everyone. I think if you are not joining us for the first time, you already know me, so I will not spend further time introducing myself since, as Ines already hinted, we have to get through a lot of material. In fact, what I will be doing in the introduction today is to try to give the very quick run through a topic that we elaborated into probably an hour and a half. At least that's our internal tests were taking that amount of time. So because of this, we will be doing the absolute minimum necessary today, which is to go briefly through these 6 topics that you see on screen. And then we will publish recordings of the 6 topics where we explain them in more depth as resources that will be permanently available. So my goal in these first 15 minutes for the concepts and then 10 minutes for the examples will be to give enough background to those of you who may be new to the trust establishment in general and specifically in eDelivery networks, enough so that you can then take those concepts to the ensuing presentations, be they the 2 examples that we will have or the more in-depth exploration of certain advanced topics that you wanted more clarifications on, which, as Ines said, will be based on your expressed choice in the poll. So with that, I would dive into the concepts, and we start first of all with just identifying what are we talking about. So what is the purpose of trust in general, not even specific to eDelivery. And of course, the key questions that we have to answer to is, who am I speaking to? How can I be sure that they are who they claim they are? And what kind of guarantees or how can I ensure that the data sent or received is authentic and confidential? So linked to these, we have 4 concepts that we want to bring from the real world, because then they will have their incarnation in the digital world. And those are identity. How can you trust somebody's identity? How can somebody prove their identity? And then how can you trust that the channel used to communicate is trustworthy in terms of confidentiality and integrity? So when we speak about identity, it is, of course, a very wide concept, but the key definition is that it is assigned to you in a certain context by, let's say, a governance body of some kind. Of course, you can talk about identity in many different ways, some of them personal, some of them, let's say, business-oriented, but from an eDelivery trust perspective, identity is something that identifies you in a certain context. So you can have multiple identities depending on the context. Now, how do you trust that somebody is who they say they are? This is a question of looking at the credentials that they can offer to prove their identity, again, in a certain context, and making sure that those credentials can be relied upon. Then how does somebody prove their identity? It is by presenting these credentials, and the one who has to validate them will have means to verify that those credentials are authentic, right? And then how do you trust in the communication channel? Well, you need to make sure that the channel you are using ensures confidentiality and ensures that the message is carried without being modified in the process. So these are the key 4 concepts that we have in the real world that we also will try to then find the equivalent of in the digital world. So the first of them was identity, and how do we define a digital identity? Well, we have a system that needs to be identified in a network, and then that system needs to receive an identifier. Much like you have your national identity number or any other type of identity in the real world, a system will have an identity in a given network. So if I am part of 5 networks, I may have different identities in each of those 5 networks, but in a given network with a given governance, I will receive a given identity. And this will be my digital identity that I not only receive and have logged somewhere, but I also need to be able to prove. And this applies whether I am sending a message or receiving a message. So whatever my role is, I will have an identity linked to the system that has that role. Now, what is important to understand in an e-delivery network is that we are talking at the same time by organizations and systems. So we typically use the identity of a system interchangeably, but it's important to be a bit more precise when we speak about what is it that we are really trying to ensure. And we could be looking at how do we know if an organization is who it claims to be, or how can we know that the system is who it claims to be? So if you look at the four-quadrant model that you are probably quite familiar with from the delivery world, you see that we have a system that produces messages, then a system that sends messages, a system that receives messages, and a system that consumes messages. So these are the systems, and each of these four systems, they have an owner. So you will have let's say typically an organization, because we are talking about a business setting typically. When we speak about the delivery, then you will have somebody who owns the producing system, the sender access point, and so on and so forth. So the key message here is you have these two entities, and in e-delivery, and this is sorry, maybe before I move to the next slide, in e-delivery, what we typically care about is the system identity. So when we talk about the digital identity of an entity, it is that of a system. Of course, there is a link, implicit or explicit, also to the identity of the organization, and the typical way you could ensure that is through having a specific type of certificate, which also records a digital certificate, which I will come back to a bit later, which also records the identity of the organization who has received that certificate. But not all certificates have this identity inside the certificate. So in some cases, it can only be an implicit association between the identity of the organization and that of the system. That is typically created through third-party means, not directly via the digital certificate. How do you get assigned an identity in an e-delivery network? Well, whether you are the producer, consumer, or sender or receiver access point, you will be assigned an identity which is going to be unique to the ecosystem that you are operating in, or in the context of which you are operating. So this will be a unique identifier. It will follow different rules. We do not have time to go into the different options here, but it's important to know that you need to receive this identity somehow from the system, because otherwise you cannot guarantee that this identity is going to be interoperable at the level of the network. Now, the e-delivery, as I said, does not really enforce the link between the owner identity and the system identity. But if you use, for instance, a signing or sealing certificate from eIDAS, then you can even capture this real life identity of the organization and match it to the identity of the system. When you have to think about the certificate that was issued to a system, well, to an organization with the purpose of operating a system, of course, there is also the question of how what was the level of assurance that this identity was checked thoroughly. And if you at least refer to the eIDAS regulation, there are several levels of trust that are established. You can say that somebody was identified with a low, substantial, or high level of trust. And this typically means, well, low, you could imagine I send an email and this is the only check which is being made. Substantial may need that I also go through some more advanced process. And high could mean that I have to either be physically present with an ID document proving who I am, or perhaps there is some kind of complex video call that I have to go through in order to establish my identity. So depending on this, of course, the level of trust you can put in the identity that is captured into the certificate, into the qualified certificate, could be lower or higher. And in fact, in the regulation, it is stated that for qualified eIDAS certificates, high level of identity assurance must be established. Of course, here we were speaking about checking the identity of the person, not of the system. Then the next question is, where do we need to establish or where do we have to trust, and what do we have to trust in an e-delivery connection? Well, the receiver must be able to trust the identity of the sender and vice versa, and both must be able to trust the channel. Of course, there is also the question of the acknowledgement of receipt that the sender receives from the receiver, that it equally must be trusted to know that the communication took place successfully. Sorry, Then we move to how can you prove identity in general and also in any delivery network. There are multiple models. We have a few that are listed in this table here. But what is perhaps important to say is that these models have different characteristics, and the model that is used in e-delivery is the PKI, the public key infrastructure, where we can check identity by or via the means of digital certificates. And there are some properties linked to digital certificates. We can trust them directly or indirectly, and we can verify them in principle without resorting to an online verification, except for where we have to do revocation checks. The identity that you have to prove in a delivery network is typically limited to proving the identity of the C1, C2, and C3. So even though C1 and C4, so the end parts to the communication, are assigned identities, these are not actively being authenticated in the e-delivery process. Of course, they may be authenticated at a higher level by the business systems, and they are carried, these identities, by the delivery envelope, but they are not actively authenticated in e-delivery access point. So this is important to know. And how do you know that you can trust the identity of a certain participant who claims to have this identity? Well, it typically requires a link between the digital identifier and the certificate, and more specifically the public key which is contained in that certificate. This link, even though it could be part of the certificate, typically is not part of the certificate, and therefore it must be registered in a third-party system. You have multiple models, but let's say that the two ones that we will focus on will be that either every access point will register this link, so I have this identifier for who can send messages to me, or to whom can I send messages, and I have the certificate of that party. If you have a bigger network with the dynamic discovery, which I will come back to in a few slides, then you can also register this link in a network central component. There are multiple models possible, but again, this is the key concept. So you have this link between the digital identity and the certificate that is ahead of time registered somewhere, so that then the members or the participants in the network can rely on this link being registered as the proof or the way to validate somebody's identity. How do you validate this identity? Typically, it's done depending on whether you are the sender or the receiver, through similar processes. So you have the two key processes, electronic signature and encryption, which allow you to validate the identity. So if I'm sending a message and I'm encrypting that message with a certain public key, then it is a sort of implicit validation, because only the intended recipient who owns the private key that is linked to that public key can decrypt it. So I am not directly validating the identity, but I am indirectly validating it by this process. Vice versa, if I want to prove my own identity to somebody else, then I have to sign a message with my private key, and the fact that this signature can be validated by the receiving party and matched to the link between my identity and the certificate is the way to prove my identity to somebody else. So when you have a sender and a receiver, as I said, the sender will prove its identity by signing the AS4 message it sends. So if the C2 must prove its identity to C3, then it has to sign the message with the private key that proves its identity. And when the receiver on the right-hand side of the slide has to check the identity. Sorry, I'm mixing this up. So when the sender must check the identity of the receiver, it does it by encrypting the message with the receiver's public key. And as I explained a bit earlier, this allows to guarantee that only that receiver can decrypt the message. And when the receiver must check the identity of the sender, it must check its signature. So these are the two processes through which in e-delivery you can validate somebody else's identity. Again, I come back to the same idea. You need the step of pre-configuring the link between that claimed identity and the certificate, because without that link, you can check that the signature was valid, but you cannot really link it to a specific identity. And this process in the previous slide was illustrated with a static configuration where the certificate and the link are pre-configured on both sides. If you are in a dynamic setting where you have SMP and SML involved, there the same checks are done, but the checks also involve retrieving somebody's certificate from the central or semi-central SMP server. I say semi-central because you could have multiple SMP servers involved. But coming back, so you would retrieve that certificate of the C3 if you are trying to send it a message from another component, not from your own local trust store. But besides the way to retrieve the certificate, the rest will be identical to the previous slide, meaning you use encryption and signature for the two cases. So when you are in a dynamic discovery situation, it's not enough that you retrieve the certificate. You also have to have a way when you receive a message to know that this certificate that you may not have configured in advance, or you will not have configured in advance, because that's why this is a dynamic discovery situation. That certificate, you have a way to accept it as being that or being linked to the identity of the sender. So if I am a receiver receiving a message from an unknown sender with a claimed identity and an unknown certificate, I need a way to check the link between the identity and the certificate, and to also establish that this certificate is legitimate in our network. And to achieve this goal, you can look at several models. I will not go into the details, but the two first models rely on the issuer of the certificate. So whether that issuer is a shared one that issues certificates for multiple domains or a dedicated one, the principle is the same. You look if the certificate was issued by a trusted certification authority, private or public, and if so, you can consider it trusted. This is quite a weak way of checking, because you are not really checking the link. You are only checking that the certificate is trustworthy. When you have a custom whitelist, whether a whitelist, whether as an SMP or as a custom third-party system, there you can check the specific certificate in this whitelist and see if it is indeed linked to the identity that you expect to receive the message from. A last note is that it's not only enough to look at the certificate of the sender and the receiver and the identity of the sender and the receiver, which was the topic so far, but you also need to be able to trust the infrastructure that gives you those certificates if you are in a dynamic discovery situation. And there are quite a few elements in place. Some of them come directly from specifications, others come by using the products. But in general, it's important that you look at the specific ways that the links between the digital identity and the certificate are recorded in the SMP, and how you can ensure that only the people who are authorized to record those links can do so. Because if this element of trust is not ensured, then of course the rest of the system breaks down. So the system is always as strong and as trustworthy as the weakest link. So you always have to look also at the trust establishment at the level of the network central components. I think here I will, in the interest of time, skip this and move directly to some examples before handing over to colleagues from DigiMove and Sweden. So let's look at these concepts a bit in real life, in real networks that use e-delivery, and we tried to select a few typologies of networks where we can explain the way these elements interplay. The simplest e-delivery network is a hub-and-spoke network with its two variants, static or dynamic. So when you have a static one, it means that there is a central access point that every other access point communicates to. So I don't have communication between the access points which are on the circle, let's say, where the spokes end. I only have each of them communicated to the central hub. So this means that it is only the hub who must have the certificate of every of the hosts, and each host only has to pre-configure the certificate of the hub, and of course the identity. I will not repeat this, but in principle, it's always this link between identity and certificate, which is the central theme of what I want to make sure is clear from this first 25 minutes. So the ways that certificate, I mean, what are the policies that each network will establish for which certificates are acceptable will vary, but typically they will be defined by the body that operates the hub. It could be that the hub is owned by a third party, and then the domain owner will be separate from the hub owner, but this would just be a technicality linked to contracts and skills. But conceptually, it is the central or authority, typically, because this you see often in a business to government situation, that will dictate the rules around certificates. You have examples such as interconnected registers, the business ones, the insolvency ones, the beneficial owners ones, or you could have regulatory requirements where economic operators have to report to the government, as in IPREL or EUDAMED or EUSEG, where you are talking about energy efficiency certificates or medical devices or tobacco reporting obligations. Etc. So this is the simplest case. Then you can have a slightly more complicated case where the certificates of the hosts are not statically configured with the hub, but they are stored in a separate registry. The rest of the model is the same, but there you would have to look at this registry when you are receiving a message from a host. And this is the case, for instance, in the DigiTaxud systems called ICS2 and CSOP, where in the case of ICS2, you have economic operators that must send messages to a central hub operated by DigiTaxud. Whereas in CSOP, it is a government-to-government example where each member state must report quarterly to the Commission on VAT transactions. So this is very similar, except that certificates are not stored statically, but dynamically. Then we move to a mesh, or an example of a mesh network. So here we no longer have a hub with the spokes. We really have a mesh of access points. And typically, if we are talking about a mesh of member state access points, then you would very often have a static configuration approach, as is the case for now in once only, where we have each member state operating typically a single access point, but in some cases maybe more than one. In any case, we are talking about a few tens of access points, and in today, each of the access points has a static configuration with the certificates and the identities of all the other access points. The way to update the configuration is that everybody must upload it to a central system, and then a new trust store is published by the support office on a secure Circa BC channel. OOTS plans to evolve to a more dynamic discovery-oriented approach, but for now, this is not the case. We have an upcoming ecosystem called EFTI that deals with showing transport documents, digital transport documents to authorities. And here it's an interesting case because there are multiple layers of e-delivery networks. So there is a similar one as in OTS between the member state access points called, in this case, EFTI gateways. Which is cross-border and statically configured. And then there are hub and spoke networks at the level of every member state, where EFTI platforms, which are certified platforms that can publish such documents, are connected to the national gateway. And there is a hybrid model. It might vary from member state to member state, but in some cases we expect that the national gateway will look up dynamically in a separate registry the certificates of all the EFTI platforms, with the potential added element that some of these may be revoked, not just for technical reasons, but also for accreditation reasons. So there might be some extra complexity where a certificate may not only be revoked in a PKI sense, but also revoked in a business sense. So there might be two registries involved. Whereas each EFTI platform will most likely have the certificate and the identity of the national gateway statically configured, because that is the only entity that they would be exchanging messages with. And I end with the example of the PEPL network, where again we have a mesh, but this time of around 1 million and growing, a number of trading parties that are using the network to exchange invoices and much more. The approach here is exclusively based on dynamic discovery for establishing trust, and it is dynamic discovery with a dedicated certification authority. So the receiver of a message, they know they can trust the identity and the certificate of a sender, because it is always issued by a specific CA, which is pre-configured in all of the systems. So this is the model that is operational today in PEPL, and I think a model that may be interesting in any similarly large e-delivery network. So with this, I hand back over to Ines for the next agenda point.
Thank you, Bogdan. So part 2, I'm glad that we are actually on time. So we have practical examples of trust models in e-delivery implementations. So first, I will welcome the colleagues from DG Move. I believe I would welcome you to share your own slides. So now is the time. So, no, you are muted.
Okay, you mentioned DG Move, so it says okay. So welcome everybody. I'm Nuno Lourenço. I'm technical architect of the reporting interface module, which is a component inside the EMSWE, which is a European Maritime single window environment. So the RIM is a project for the shipping industry in the member states, where the ships need to submit some reporting. So this is to receive and handle this reporting. So as we see here, we have 22 member states, and we include Iceland and Norway as the economic space, and we provide a harmonized interface for reporting and a common data set. And something that we'll mention later, common user registry and access management. This component will certify that the intervenient in the network is trusted. Normally it's by a sender, and the sender can be a declarant or a service provider. So this is the boats entering the ports in the member states. So the RIM acts as a corner 3 and is normally controlled by the member states. where they receive the formalities submitted by the shipping industry. And it functions as an IS4 access point, as Bogdan mentioned in the slides before. So each member state needs to host a RIM instance. It means that shipping industry will also use AS4 as corner 2. And as we see here, this is all built on top of AS4 protocol. The RIM is developed by the Commission and is deployed and operated by the member states. So the member states are responsible for the RIM deployment as corner 3. As we have seen in the previous slides, so this is based on the 4-corner model. And here we have the sender, which is the shipping industry, as corner 1. It's typically a back office. And corner 4 is another back office controlled by the member states. And in between, we have the AS4 corner 2 and corner 3. So as I said, the sender is normally a declarant or service provider, and the MNSW is the member state which hosts the RIM. So the component 4 that I mentioned for managing the trust to the senders. So how does this 4-corner model and the RIM project trusts the stakeholders in the network is via URAM, which is User Registry and Access Management, which is a component hosted elsewhere. So this is typically the EU access in the Commission that the member states need to register. So every sender in the either declarant or service provided needs to be registered beforehand in a portal supplied by URAM, where they register their economic operator number, which is this area number that you see in the table, and the certificate. This certificate normally it's a ADAS certificate. And we propose to use the qualified ADAS certificates, but the member states can also use advanced signature. So this system will host the pair EORI number and certificate, and with the domain which corresponds to the member state. So this sender registration is unique across the network. So they are introduced in the system in a member state. And as I said, it stores the pair EORI number and digital certificate. And digital certificate is ADAS compliant for security and trust. As we saw before, there are other certificates that will come that ensure also signature and encryption in the AS4 network. But for the business layer, let's say, they need the ADAS compliant certificate. Also, there is 2 possibilities in the RIM for the validation. So when the sender submits a message, this URAM can be validated centrally. So URAM hosts this central registry that we see here in the figure, or they can store in a national registry. So the member state can ultimately store the certificate and the EORI number registration, and URAM acts only as a proxy for validation. So the validation service is always supplied by URAM, and it can go against the central registry hosted by them or the national registry hosted by the member states. So here for a full diagram that includes the URAM, we have the 4-corner model, and as you see, we have the sender domain, which is the shipping industry, and the member state domain, which is the member state hosting the RIM. And both are AS4 access points, and the RIM is a plugin on the Omnibus, which is the e-delivery implementation of AS4 profile. And below, this is the central European Commission domain, which hosts the URAM validation service. So in this case, in this slide, the senders are stored in the central registry, so they always consult in their own table. So as you say here, the validation is always done in URAM, and the sender signs the business documents. So the business documents are formalities that the shipping industry needs to submit when entering a port. And this is the validation is we extract the ADAS signature, and with the URI number, we call this URAM validation service that validates the access. So this is the central registry. In the next slide, we'll have the national registry, which is the same flow, but as you see here, the URAM validation service calls the national registry, which is in the member state domain. It can happen that, let's say, this member state domain is Belgium, but the ship is from Netherlands, and this national registry is in the Netherlands. So it can be in several registries. So as we say, we have for the REAM basically two layers of certificates and trust. So as we mentioned, ADAS certificates are used to sign business documents by the sender, and this represents the business layer of certification and trust. So they use an ADAS certificate even before corner 2. So in corner 1, they'll have a back office that will sign the PDF of the formality to send, and they wrap it in a concept that is an ACID container that we'll see later. This container wraps the ADAS signature and the formalities, and wraps it also in an AS4 message before sending to corner 3. And as a second layer, the transport layer, and as we saw before, the AS4 access points, they use these PKI certificates for signing and decryption. So the corner 2 will use these certificates, and the corner 3 will use these certificates, both for signing and decryption. What we usually recommend, since the European Union trusted lists of qualified trusted service providers, these are the service providers that provide ADAS certificates. Since they are providing the ADAS certificates, the member state should also use this trusted list to obtain the public key certificates to configure in the access points, both for the senders and member states. So these certificates will be used as message level signing and decryption between the AS4 nodes. And of course, the URLs are protected under HTTPS. So this is the full diagram with both scenarios. And here we can see the different kinds of certificates and trust in action. So in the first block, we have this ADAS certificate that is used to seal the message, our ACID container. And the sender sends to the corner 2 to be delegated to the corner 3 AS4 access point. So this is the REAM plugin under Domibus. And we can see here this channel is protected by TLS certificates. And corner 3 then receives, and in this case is a mutual TLS channel, so it's like a two-way SSL. And this is a REST service provided by URAM, which does the central authentication. As we saw before, this can be verified against the central registry of senders or sent to a national registry, which is also protected by a TLS channel. So as we see here, we have several types of certificates. One more for the business layer, which is ADAS certificate, and another for the transport layer, for the AS4 channels and other REST service call. So this is the full scenario of the REAM. We also have, before going to the description of the ACID container, we will also have the possibility, as Bogdan said before, of using SMP, but this is an optional service that we're still in the beginning, but that may be included in the MSWA network for dynamic discovery, as opposed to the static discovery, which is the default discovery scenario. So The next slide will show the type of message. So after we sign a formality with a certificate, we bundle it in a SIG container, which contains the signatures, the formality, which is the signed document that the shipping industry sends for the member state, and any potential attachments. And the REAM on corner 3 will also verify the integrity of the payload by checking the signatures and the contents of the container. And this is how we send formalities in the REAM network. So this is it. Thank you for listening. We have here our mailbox if someone wants to ask a question.
Thank you, Nuno, for your presentation. Just to clarify, indeed, Nuno is from Digit, but the policy owner of the project is indeed Digimove. Just this small clarification. Thanks a lot, Nuno, for your presentation. So, small reminder that the poll is still open for the part 3 of our webinar, and you can also still continue to use the chat. So with no further ado, I'll pass the words to our Swedish colleagues. So to Stina Hedlund from DIGG, so the Swedish Agency for Digital Government, to present us the Secure Digital Communication Project.
Thank you. I'll just share my pictures. Yes, I think it's correct, and I will just put up something here so I can point. Yep. As Ines said here, I work for Swedish Agency for Digitalization, and our mission that is to coordinate and to support the joint digitalization to make public administration more efficient and more fit for its purpose. We also are responsible for ENA, which is Sweden's digital infrastructure. We follow up and analyze the digitalization of society, and we also help the government and the public administration to make well-informed decisions. And we are also one of the Sweden's emergency response authorities. About me, my name is Stina Hedlund, and I'm a specialist and also product owner at DIGG. And you can see my email address if you want to get in touch for some questions later on. We provide a digital service that is called Secure Digital Communication, and that one is a cross-sectoral exchange of sensitive personal information in a secure way. So it can be used for both authorities and municipalities, and everyone that is in the public sector can join to our federation. And it's a safer, simpler, and more efficient alternative to telephone, fax, or letters that is now very commonly used in public sector for healthcare and school and social services. And the trust model here that we are supposed to talk about. We have a federative contract model for our service. And you can see here, messages are sent peer-to-peer, transferred synchronously here, the generic transport infrastructure, e-delivery, you know all of that, so I'll just skip it. But what is special for our model is that we use the message encryption and signing between each participant's messaging service. And also we have an address book that is for participants to find each other. And a little bit more about this federation. We have participants in the public sector, as I told you, authorities, municipalities, regional healthcare, etc. Around 180 are connected right now. We started around 2 years ago, and 2 years ago it was 4 or 5 that was connected, so now we're 180, and the many are connecting right now. We have access point operators. It's 18 now in a total. And we also have special providers of software for messaging. And this one is a bit more advanced messaging than the ordinary. So we have 7 providers of software for messaging. DIG is the owner of the federation, and we also administrate the regulations of the federation. That is a very important part. And in this one, we have rules for how to handle the information security in your organization, how to send messages, and it's a lot of regulations to connect to this federation. We are responsible for the software for the address book, and also we have contractual relations to every party that is in the federation. If we look at the contractual relations, we have us, DIG, that is the federation owner, and we make agreements with the access point operators that are within the e-delivery, the corner 2 and 3, as you're familiar with. And here we make an agreement that they are compliant to the regulations of the Swedish implementation of e-delivery. And these access point operators, they must pass the mandatory conformance tests. And also we have the messaging systems and the providers here. We offer them software, which they must do conformance tests to be able to operate within our federation. And also they have to assure on compliance, but we don't make agreements with them. Instead, it is the participants, the corner 1 and corner 4, that for joining the federation, they need to have one of these messaging systems. So they need to make an agreement with one of those, and also one agreement with the access point operators. If it's a larger company or a larger authority, they can also build their own systems, but they also have to pass the tests and everything is working. The participants, they also need to make an agreement with us, the federation owner, DIG, and that agreement is on compliance to the regulations of the federation, and they also must pass mandatory conformance tests. The trust model. The federation is a responsible organization for identification and validation. That is a know your customer process. We also demand that a strong authentication is used for authorization of administrators, and we use administrators in the address book to upload certificates and also for changing metadata. The validated organization's metadata, that including certificates, and that is a public key, is registered and signed in components managed by the federation. I will soon give you a picture of it. And we use several CAs. The TLS CA is managed by commercial CAs. That is a mutual TLS. And also the AS4 certificates is managed by DIG. Then we have a message organization to organization, and those are specific commercial CAs that we use. So in this picture here, the access point operators, they need to have a transport encryption, mutual TLS certificates, and also AS4 encryption and signing certificates. But then there is this central part here, and that is the participant organization, and they are one independent security layer. And here they use message signing and also encryption. So it's organization to organization certificate. And everything here is signed participant metadata by us. How to send a message. Okay, we can see here we have one party that want to send a message to one another. You get the user interface, and also we get the participants, the higher messaging software, and we get the access points. So if we want to send here, we use this address book. That is one very important part. And we have this SMP and also the CertPub, as we call it, that where we publish the public parts of the certificates. So we have some sensitive information here on this screen, and we want to send it to another party here. So this could be maybe the public deployment agency or employment agency who wants to send it to maybe a municipality. So they search for the address in the address book here, and after that, they press send, and they send it to their own messaging software. The messaging software, it validates the receiving address from the address book, and also from the place where we publish the certificate, it gets the receiver's public certificate to encrypt the message. After that, it moves on to the access point, and the access point gets the service metadata as you're used to. Then they send the message to C3. And after that, it goes to the receiving party's messaging software. And they validate the sender's address from the address book, so they can see that, okay, it's correct. And they also validate the sender's signature, so they know, okay, it's from the right organization and everything is fine. So then the message is sent so it's readable in the user interface. So that's the way it works. And we have been talking about trust here, and one very large part in the trust here that is onboarding of participants and also onboarding of the access point operators. So let's move on to that. All right, we start here with the organizations. They make an application and they need to be conformant to rules and specification, legal agreements. They need to also report who should be their authorized administrator and which message system and access point operator they want to use. Their application is handled by our case management that also go through validation here. So they check public records, they check the organization type, is it the correct authorized signatory, and also is the domain address, is that do they own it themselves or is it not that? So this can, maybe you need to check it a couple of times here, but after everything is fine, we send them a signed agreement here and we register the organization. In the database, our database, we register the organization and also the authorized administrator. And the organization can then move on to procure a certificate. We use only authorized CAs and OV class certificates. They can register the certificate in our e-service after they have made a strong authentication of the authorized users. After that, we receive their certificate, we make a validation of the certificate. And after that, we publish the official parts, the public parts of the certificate, and also the public key here in the database. And the onboarding is complete. After that, the organization is ready to communicate within the federation and to send and receive messages. They can also create addresses in the address book. And we have validated the organization's identity. We have also made sure that the common rules and specifications are enforced by the legal agreement. And we have published the organization's certificate in the component CertPub. And also we have made sure that we know who is authorized user for administration and they are registered. But please note, excluded in this illustration is all the conformance testing. That is, we didn't bring it in here. We would have needed a few more hours to talk about that also. And for the access point operators, it's much the same. They make an application on how to join the federation. They need to follow conformance tests here and legal agreements, and they have to report who should be their authorized administrator. Everything is handled by our case management. And also we make here validation of the organization and checks in the public records, and that is a correct person who has signed everything. After that, we make a registration here, and we, in the database, register the organization and their administrators. So we can use that for later on. And after that, the organization can create a CSR. And that is through DIG e-services that they make it. Then we create the certificate for them, AS4 certificate, and they register it in our e-service. And then we once more we make a validation of that certificate, and we register the public key in our database for AS4 certificates. And once that is done, the onboarding is complete, and the access point operator is ready to deliver and to receive participants' messages. And the result here that we have an organization that has a validated identity. We made sure that common rules and specifications are enforced by the legal agreement. And the AS4 certificate is registered and published, and also the user for administration is registered. And the access point operator can also register its participants' metadata, and that is published after federation validation of the organization. Also here we have skipped the conformance testing process, so that is not part of this picture, but it's a big part on how it works. That was my last picture. So we can you can contact us at this email address, SDK Secure Digital Communication, but with a K, yes, it's Swedish we're speaking here. And also we have a website where everything is published. The website is unfortunately in Swedish only, but there are excellent tools to translate it to English, so I think you can manage that anyway. I have two colleagues. I don't know if there was anything in the chat here.
Thanks a lot, Stina. I've been following the chat, and I don't think there were any questions for you specifically. Thanks a lot, Stina, for your presentation. Regardless of that, of course, we keep the chat open in case there are specific questions that we can address during the presentation. Thanks again, Stina, for your participation today. So we move on to part 3. So I'm glad to inform you that we have some winners in the poll. So before I move on to presenting the section, so we have 4 winners. So system-to-system trust, end-to-end trust, common challenges when implementing a trust model, and if we still have time, digital certificates and e-delivery and QERDS according to the EIDAS regulation. So I will share now the slides for part 3. Normally you should be seeing my screen. If not, let me know. And I welcome Vlad Veduta on stage to address this part of the presentation. So Vlad is a business analyst in the delivery team in DIGIT, European Commission, and Vlad will be taking us through the results, let's say the topics that were chosen by you to be addressed in this part 3. Just a reminder, so these topics that you all voted on just until now, they were selected following the feedbacks that we received during the registration to the webinar. So it was based on your feedback here. So I welcome Vlad to speak for the topics that were selected, and these relate all to the business perspectives of trust, related, of course, to the trust models in e-delivery. So Vlad, you are welcome.
Hello, Ines. Let's maybe go back to the summary. Hello, everyone. I will read the titles and give a small explanation on each topic. System to system and system to user trust. It is a topic that we prepare as an answer to questions related to how could e-delivery be used in setups that address customer to government or business to government or citizen to government or citizen to citizen or business to business. So in this perspective of government versus citizens versus business, how can be e-delivery used in such scenarios? The second topic, it's about digital certificates, and this was pretty straightforward. About questions were which are the right digital certificates to be used for each purpose with e-delivery. Third topic is about end-to-end, and we see this question pretty often linked to the four-corner model where sender and the initial sender and final recipient, how they can make sure that their identity is checked and assured, because normally delivery will be dealing with the trust between C2 and C3. Point D is the additional trust that comes from the underlying network. This was, we see the question, can we deploy delivery on top of trusted networks like private VPNs, like Testa, for example? What are the consequences? Is it possible? Is it recommended, etc.? We have a single hop versus multi-hop question that addresses how trust work in a peer-to-peer network versus multi-hop one. There are AS4 networks in Europe that use this multi-hop setup. Point F speaks about what are the enablers, what are the challenges when setting up e-delivery networks in member states, and how does this changes when you want to have these networks set up to be cross-border, so cross-European networks. Next point is usually trigger. We see this question, if someone has an access point, can it participate with that access point in several networks? Can they use their access point? Do they need to deploy several access points, etc.? Fourth question, question H is linked to e-delivery and QRDS. How does e-delivery lead to QRDS and ERDS in the eIDAS sense given by the eIDAS regulation? Last point is common challenges. This is self-explanatory. I see that Ines, please confirm, we'll be moving to system trust. This is the number one voted topic.
Yes, thanks, Vlad. It's confirmed. So we start with topic A.
Yes, topic A. So the question we gravitate around with this topic is in the scenarios when we want to set up systems that are scenarios like customer to government, government to government, business to government, and any combination between these roles. How does e-delivery relates to this setup? And I will start by underlining that e-delivery is a machine-to-machine protocol, and this makes it a bit already hitting in the direction that it would be mostly usable between organizations. So it is that organizations will own access points. Citizens, like end user people, will not normally deploy or use an access point. And in relation with this, with citizens, most likely an intermediary service needs to be used by these end users. So the idea is that e-delivery does not prevent citizen to organizations setups to work, but this would be achieved in at least a two-leg setup where you have an intermediary service that is facing the citizen, and then you have this interface of the system to the organization, be it government, be it business, where e-delivery can be deployed. In short, e-delivery can be deployed between business to business, business to government, government to government, etc., and needs intermediary service to speak to citizens. And we can move to the next slide to see how e-delivery would be used with scope that we mentioned earlier. So we selected three use cases here. The most simple one is when the number of participants is reduced. So if you have, we set a threshold of 50 access points for the complexity. If you deal with less than 50 access points, the recommended setup is that you go for the static configuration with mutual trust. And every access point will know the other access points, and everything is trusted directly and straightforward, with the overhead that every access point will need to maintain this by itself, these trust relations with the other points. We grow a bit the complexity and we go to the star topology. Also, we refer it to hub and spoke. We see this in setups where maybe business organizations want to report to a central government organization, or the other way around. Maybe a government organization wants to notify business organizations about some event. And we have government organization being the central point, and we have hosts from the hub and spoke as business organizations. For this setup, we will allow and we recommend that we have a static configuration on the host. So the business organizations only configure statically the central node. They need to know identity and trust the central node, and this can be configured statically. While for the central node that has to deal with several organizations, increase a number that may vary, we recommend to go for a dynamic discovery, PKA based, and that's the setup we recommend. The most complex setup is the third use case, where we have this mesh topology. When everybody speaks to everybody, we can have government actors and business actors as well. And for this large number, all nodes will need to use dynamic discovery. And this again, we recommend it is PKA based. So there is some certification authority that will issue certificates for the participants in the network, and having also government actors involved in the network. It might be also the case that we can leverage some policies or rules around how the certificates will be created, and in this way enhance the trust in the certificates in the network. By explaining this last use case, I finished this topic.
Thank you, Vlad. So the next topic under the poll that won the most votes were actually two at the same time. So I believe we should focus on both. So we have end-to-end trust first, and then we have common challenges when implementing a trust model. So Vlad, maybe we can move on to the end-to-end.
Yes,
trust.
it's about end-to-end. Okay, so what was the issue addressed here is that in many four-corner setups, there is the need that C4 makes sure about who C1 is, and the C1 also wants to make sure that the message will reach the intended C4, exactly the C4. There are several ways of implementing such, of answering to this requirement, so implementing such trust. We've seen one solution to this in the presentation made by our colleagues in Sweden already. This is the first case, which is the direct C1 C4 trust. This solution is built on top of eDelivery, so it's not provided by eDelivery, but it usually assumes that C1 and C4 will use their own cryptographic means to sign and encrypt the payload that is being transmitted over eDelivery. This will provide the required trust, but yeah, it brings logic to C1, requires logic to C1 and C4, and it makes them aware of cryptographic implementations, which might be seen as a burden for C1 and C4. Next solution we are considering is having this C1 C4 trust achieved by trusting all the legs or steps in the communication. We mean by this that you will be trusting the communication between C1 and C2, then the communication between C1 and C3, and at the end the communication between C3 and C4. So you will be trusting the chain by trusting every link. This use case also splits into two subcases, and the logic to split is considering who is the legal person that owns C1 and C2 and on the sending side, and maybe mirrored C3, C4 on the receiving side. If there is the same legal person that owns C1 and C2, and this might often be the case because many organizations will choose to deploy their own access points. So they will be the owner of a business system producing the message as well as the access point sending the message. There is actually no trust issue between C1 and C4. There needs to be security between C1 and C4, protecting the channel, etc. Especially if C1 and C2 are not collocated. But from a trust point of view, there is no legal issue, being the same person that is representing both systems. The most difficult scenario comes when C1 and C2 are owned by different legal persons. And this is a common situation when we have, for example, users of eDelivery service provider. So we have organizations sending their S4 messages by connecting to a S4 service provider. Then it's obvious that the C1 and C2 are separate legal person. This issue is solved by eDelivery by delegating on the sending side C2 for ensuring the identity of C1. So C2 will create the means to authenticate C1, and it will include its identity in the message it will be sending to C3 in the envelope in the field original sender, and it will also vouch for this identity by signing this security header. This is called delegation because C3, C4 delegate C2 for performing the identification of C1. Things happen in a mirror of C3 and C4. So C3 will be delegated for authenticating C4, and C1 and C2 will be trusting C3 for achieving this task. eDelivery says that this delegation needs to be done. So C2 and C3 have to do the authentication of C1 and C4, but there is no specification on how. So we do not prescribe a way of doing this. There can be many solutions used for this purpose. I think that's our answer to this topic. I don't know if there are questions, or we should move directly to the next topic.
I think we can move to the next topic, unless my colleagues suggest otherwise, and we can take questions at the end. Next topic are the common challenges when implementing a trust model, Vlad. So I'll move on to those slides.
Okay, this is one of the last slides. Yes, this one. Okay, so we have here some challenges that we selected. They are not linked to a specific trust model. Is challenges that I think each of them is specific to a certain trust model. What I can tell is that the less challenging to implement is the static mutual trust, so the one that deals with the smaller number of access points. That one is the most straightforward to implement. Most of these challenges are linked to the dynamic way of ensuring the trust. And the first one we see is that many times we recommend that the trust is linked around certification, generic certification authorities. So certification authorities on the market that will issue certificates and will be trusted because they are deemed to be trusted by the business environment, like big players like Microsoft, Google, etc. And while these certification authorities will give you, these certification authorities are very trustworthy, so they will give you strong certificates. They are also a bit rigid when they might need to adapt to some rules domains will ask them to create. With some domains, if you want to use this kind of certificates and you want to make sure that the certificates will be issued according to the domain rules, it will be often difficult to agree these rules with the certification authorities. I'll move on to the next challenge that we identified. It's also linked to dynamic discovery. I think in the presentation of Bogdan, we mentioned several times that a whitelist is indicated to be used in the case mainly of the dynamic receiver. And while the whitelist is a very good way of performing the dynamic authentication, for now, we don't have with the delivery, we did not select specification for this, how this dynamic, for the API of this dynamic list. We are looking of SMP as a candidate specification, but also other solution like decentralized identifiers could be used. We even created a couple of years ago proof of concept using blockchain technology to achieve this list of trust for the delivery. Third point we touched in the end-to-end slide previously. It's about providing tools, the exact toolkit only for C2 and C3 C2 to C3 communication, and while assuming that C1 and C2 is secure and trustable, e-delivery does not prescribe an exact solution in there. And it's often that we get a question about how should this be done. It can be done in many ways, but we don't say exactly how this should be done. Next point, it's linked. We identified this challenge when it comes to QERDS. QERDS specifies a top of requirements on top of ERDS according to eIDAS, and one of these requirements is to include in the signature qualified timestamp. And what we can say for now is that the format we are currently using for delivery signature, which is the XML digital signature, does not foresee this qualified timestamp in the signature. So this is a bit preventing the full compliance to QERDS. This is still compliant with ERDS, but with QRDS we have this explicit link to qualified timestamp. And the last point, we've seen this when discussing data spaces and how to deploy delivery of data spaces. And we've seen that with data spaces, it is often the case that the data space has itself an infrastructure for providing the trust, like identification, authorization, authentication, even authorization. And with the current e-delivery, we don't have a way of simply plug in the mechanism of the data space. E-delivery comes with its own mechanism, and this cannot be easily replaced with one of a data space. The other way around, if a data space can do it, this would work, but again, it might be moving the challenge to them. So these are the challenges we find.
Thank you, Vlad. Thank you, Vlad. So my colleagues informed me that the next topic is digital certificates. So I will move to those slides. Okay, here we are.
Ahead. That's it. Okay, with digital certificates, the question is straightforward. What certificates, where to get them, and what kind of certificates? And to answer the first question, where you can get the certificates, there are 3 ways you can get a certificate. First way is you get it from a certification authority. This can be generic one, or could be one from the list of trusted list, but it's still a similar process to get a certificate from a certification authority. The second way is that you get this certificate having it issued by some organization that is not by the business means a certification authority, like your own organization or some organization that was deemed by the business domain to be the certification authority for the network. It can also be a list of organizations that could issue these certificates. And the third way is that you create your own certificate. There are tools, OpenSSL, to create a certificate, and this will work with e-delivery. But we need to look next at the source of trust, because whatever certificate you get, the first challenge is that your certificate will be trusted by the participants in your network. And for the source of trust, we identified 3 scenarios. First would be the European list of trusted list, which is a tool built exactly for this purpose, and that has the advantage that it works cross-border. So one certificate that is issued according to the laws of a member state would be immediately trusted in the other member states, because the certification authority that issued the certificate is listed in this list of trusted list. So this was built as a tool to overcome the cross-border trust challenges. The second scenario is the most common one, also the most used by us, also before the list of trusted list, is to use the generic certification authorities from the trust market, business trust market. The trust here is governed by the big actors, which are the big root certification authorities, along with these big companies, players that are building browsers and application servers, etc. And this is there are audits and certifications, mostly non-European driven, but yeah, they are proved to be a good source of trust. And by how to use this kind of certificates, normally your access point will work with Trustor, and you will be populating your Trustor with certification authorities of this kind. But as opposed as your browser work, and it starts with a big list of trusted certification authorities, your access point should start with an empty list, and certification authorities should be added to your Trustor only per need. So if you communicate with some party in your network and they give you their certificate and they say you need to trust it, you need to trust this issuer, you add this issuer to your Trustor. And it's also important that you remove that issuer from the Trustor, that the trust relation is not no longer. The third source of trust is this custom approach, where you trust certificates because they are issued by authorities that are on a list that is trusted by your domain. So how this list for the domain is segmented can be a static list, like you have a free organization, you have a set of 1, 2, 3, 4 organizations that issue certificates, and you can trust those simply, mostly because you will trust the certificates because they are issued by these authorities. Let's move to the next slide to speak about what kind of certificate you might want to have. And when we speak about what kind of certificates, there are two types of certificates that are used by delivery. There are the certificates that are used to sign and encrypt the AS4 messages, and these are what we call the EBMS free certificates linked to the EBMS free standard that describes how this works. And there are also the TLS certificates that are to be installed for the TLS communication on the e-delivery nodes. Well, when you want to get a certificate, you need to figure out which type you want. So assuming you want EBMS free certificate, then if you go to your source being a certification authority from, let's say, list of trusted lists. So according to eIDAS, you would be looking for a ESEAL certificate or a qualified ESEAL certificate from this type. If you are getting the same certificate from a generic organization that is not governed by a list of trusted lists, the most suitable types of certificate according from the requirements that are issued by these organizations would be the SMIME certificate. On the other hand, if you are looking for a TLS certificate, the eIDAS and list of trusted lists will also give you TLS certificate according to their list. So there is this trusted service for a TLS certificate. Or you can get the same certificate from this generic authorities, and from their offer, from their requirements, you would be selecting the TLS server certificate. So this is how you pick your certificate. These are the types that are available. And still with this type, there is a word to be said about cryptography for the certificates. There are several algorithms that can be used to provide the cryptography of the certificates. Until last year, with eDelivery, and still persists, is still valid, eDelivery version 1.15, we are using RSA cryptography, but from eDelivery 2.0, we are moving to ECDSA and EDDSA cryptography. What we've seen is most certification authorities will be issuing ECDSA certificates, but not so many will give you the EDSA certificates. Still, if you are working with, let's say, option free, like organization issuing certificates, this type of certificates can be easily created by a certification authority of your choice, if you can agree with them to do this. With the TLS certificates, eDelivery mandates TLS and recommends a list of ciphers, cipher suites for the TLS certificates. And we can see that most of these certificates are available from the providers. So there is no issue with the TLS. I mean, there is no issue with the others, but there is not a lot of attention you must pay to the TLS certificates. You must need to select a cyber suite. And that's it about certificates.
Thank you, Vlad. So I believe we can move on to the next topic.
There is a question in us.
Okay, yeah. Do you mind either saying out loud or
Yes, I can read the question.
Yeah, okay, good.
Do you see challenges with the EBMS 3 certificate and key usage, specifically content commitment, aka non-repudiation? As EBMS 3 is machine to machine, how can we avoid abuse of these to sign business documents?
Thanks, Bogdan.
Well, we don't see any challenges. I said already ECDSA are available. They are indeed issued to, if you go to source 1 or 2, they are normally issued to organizations. But yeah, they can be deployed on machines and used to encrypt the communication between machines. So, I don't know if this answers the question.
I think the question is, how can we prevent, or is there any concern about preventing that the same certificates that are used for AS4, EBMS 3 are also used for business documents signing? In other words, do we have any advice about the key usage that should be enforced on those certificates to avoid that they are used for additional purposes than AS4 communication? Perhaps if I'm wrong, can be clarified later in the chat.
So about reusing the certificate, technically there is no issue, and also technically we don't enforce the certificate not to be reused. From a business perspective, it might make sense that you want the certificate not to be reused, but this needs to be enforced by process and procedures in your business, because one system will not be able to know that the same certificate is used by another system.
Okay. Thank you, Vlad.
I can add a quick clarification. So in the end, if the concern is for a certificate not to be usable by anybody else except the eDelivery access point, I think that the key question is, how do you protect the private key and access to the private key? And there is indeed where you have to have organizational measures in place to protect that only the eDelivery system can access the private key. Perhaps this cannot be forbidden technically to the system administrators, but typically there can be solutions to prevent usage of the private key by anybody else except the eDelivery access point. Incidentally, I think this could also lead into a discussion about the usage of HSMs for storing private keys, where perhaps there are various authorization options available, which may depend on the HSM product for securing access to the private key, so that it can only be given to the access point, and anything else could be under tight control.
Okay. Thank you, Bogdan, Vlad, and for the question itself. So we can move on to the next topic, which is participating in more than one eDelivery ecosystem. Vlad, I believe the slides are... yeah, okay.
This one. Okay. This question comes often linked to reusability. We have participants in some network asking. We also have an access point in a different network, or we know some organization that has an access point in that network. Can we reuse that access point. And we respond to this question with 3 slightly different use cases. They are a bit similar, but they are also different. And the first use case is the most straightforward and simple one. And in this use case, we can say, yes, you can use the same access point, but you might use a different identity in each network. So what do you mean by this is that you can be a participant to network A and network B, but you would have an identifier and then the certificate in network A and different identifier and a different certificate in network B. You can communicate in both networks, and there is no, let's say, need, but also it is not prevented that you be somehow transmitting messages from one network to the other. So you can do it, you cannot do it. It's in the logic of your access point, if you have the need or not. This is the most clear setup, but it does not reuse your identity, which is actually the use case 2, where you have a participant in network A that wants to exchange messages with let's assume every participant, not every, but several participants in network B. But if you go with several, it's also what you need. And the key here is that this participant in network A will want to use the same identity as in network A in order to communicate with participants in network B. And this has a straightforward solution as long as network B has a static configuration with mutual trust, because every participant in network B that wants to communicate with our user in network A would simply add its identity to its configuration and trustor, and then the communication will be enabled. Things get complicated if in network B you have a dynamic discovery, and there you would be admitting communication with this participant using some dynamic rules. In this case, network B as an entire network will need to adjust its rules to allow participant in network A to transmit to participants in network. This might be straightforward, but it comes with some concerns that by simply relaxing the rules in network B, some security breaches might be created in network B, and as a consequence, it might happen that you actually allow more than intended participant from network A to join your network. So this is feasible to some extent, but it comes with this challenge, and this challenge needs to be addressed looking at the rules that exist in network. And the third use case that is very similar to the first use case as solution, but as a problem, it's a bit different, is that you want to exchange messages between network A and network B. So every participant in network A and network B want to exchange messages, but you do not want to change the trust rules in either network. So not in network A, not in network B. This can be achieved with a setup similar to use case 1, where you select one access point that will gain identity in both networks. And so there will be different identities in each network, but this access point you will be using as a bridge. So what you need to do is to set up this access point that can exchange with one identity messages in network A with the other identity message in network B, and you will be creating some logic on the access point that the access point will be able to transport messages from one network to the other. So you might receive messages from network A and forward those to network B and the other way around. And this way you create kind of a bigger network, but without changing the rules in the networks that compose this new network. And that's the content for this topic.
Thank you, Vlad. I believe now we have time for questions. I cannot see the chat, but we can also invite people to speak up.
There are no further questions linked to the topic that Vlad has presented. So I think we can, as you said, take questions linked to any of the presentations that you saw today, whether the last topic presented by Vlad or earlier topics, or the two presentations from Sweden and from the Commission on the Maritime Single Window, or the topics at the very beginning. So this is the last slot in the webinar for Q&A.
We still have some minutes left. So this is the time for your questions, as Bogdan was saying. Okay, I see that we have hands raised. Please go ahead.
Stefan Engberg. First of all, these are complex questions, but I think that what I've seen today is very concerning, to the sense that you are always assuming that trust is about identification in infrastructure, and thereby you create a fundamental problem where the control always transfers from the entity in question to infrastructure, and we have no means to secure that. That is for both citizen level, corporate level, government level, and especially the military, because you die in the military if you think like that. Okay, so we've been working a lot with identity from a citizen perspective, and how do you create new identity that's unlinkable, and what is coming in with IDAS 2.0, which I don't see discussed here at all. But what we're working on right now is for the military to how do you secure transaction and infrastructure so that all transactions look alike and you can still communicate. And you need to have a different kind of thinking in trust models if you want to do that, because you really want to focus on what you are and have gradual resolution of what you are instead of focusing on who you are, as the trust models do. It's very abstract, I know that, but that's what I got for an introduction like here. I don't see it as an inherent problem in e-delivery, but I haven't seen any of the presentations even mentioning this kind of this level of problems, which I think is very, very fundamental to EU problems today. Because what we're doing is that we are building very bureaucratic rules resolution on top of surveillance. And a lot of what we try to resolve in the rules level should be incorporated through credentials and locked, so that we don't create all sorts of secondary problems. I think I will rest here, because I think it's for another time, and it requires better introduction to the issues and how to resolve them. But I would just warn you that there is a deep and inherent problem in the way that we assume trust in this setting.
If we could continue briefly the conversation, and thank you for your intervention and also the earlier messages in the chat. I think we want to look at this further and exploit, let's say, your experience in the topic. So what is important is if you can make perhaps in the form of a change request, if you can make a proposal more specifically aimed at the delivery, because what is unclear at the moment is that you had a few interventions linked to the fact that we demand that access points be identified, and certainly they have to be identified, but the identifier doesn't have to be linked to a physical or to a real world identity, right? That's what we discussed in the beginning, that the identity in the end is assigned in the context of a specific network. And if in a network the identity is a string that cannot be tied to the person, in some sense you have an unlinkable identity. And similarly for the certificate. So I don't see yet the fundamental.
Well, yeah, the assumption there is wrong. I mean, what you should consider is to shifting the level so that you start unlinkable. Okay, you want a qualified identity. That means you want to have assurance that the hardware and the structures behind this is something you can rely on. But in the transaction, you want unlinkability so that you can lock data and the process to the purpose instead of exposing the ones interacting. That also means that you need to reverse the thinking so that you have conditional mechanisms in case, for instance, that you break a contract or whatever you do. But these are exceptions to the general rule. So, for instance, if you include a proof so that a judge can identify you in case you do something wrong, then a judge could decrypt this in a certain time period and then never more. But in normal circumstances, it will never happen. So it means that the transaction remains locked to the purpose instead of right now where we see the surveillance capitalism and all these even worse structures centralizing control to locations where we can't trust it, we can't secure it, and we can't make it effective. It's not adaptive in the perception. Is this clear?
I think it would be difficult for us to translate your problem statement into a concrete approach in e-delivery. That's why my suggestion was if you look specifically at e-delivery, if you want to engage with us in the specific context of the middleware that we are in charge of, so to speak, which once again I repeat is not meant as a solution for every governmental or business to government network. Quite the contrary, our vision is that e-delivery is a value proposition which brings a certain approach, a complexity, and set of constraints. And every business domain has to look at their needs and see if they find a match with e-delivery. So in that sense, I think there is no regulatory force behind the delivery as such. This is brought by a specific domain, and indeed there are areas in the Commission policy where e-delivery has been selected. But it doesn't mean that e-delivery as a set of specifications and as an approach is enforced on any specific domain. Having said that, coming back to the request to you or to the suggestion to you, if you look at e-delivery as middleware that is general purpose, that can be adapted and reused in the different domains or counter-selected against, let's say, if not suitable in a certain domain, say military or otherwise. But if we want to improve it to make it better so that it can be used in other domains while retaining more or less the core tenets of what we are doing, because if indeed we are talking about inventing something which is not e-delivery, then we are probably the wrong people to talk to, because we are here mainly with the mandate of maintaining e-delivery and evolving it, but in certain ways, not necessarily replacing it with something else that might be somebody else's mandate. So if you look at the delivery more or less within its current definition, and you say we can make it better by changing the approach to identification and PKI, etc., in certain ways, it would be very helpful if you can request and say, okay, this is what you have, this is what is wrong, or this is what is not optimal for certain use cases, and this is our suggestion. Then we can have a look at that in the sense of trying to see if it makes sense for us to incorporate it in a future version of the specification. Because then we can say, well, for instance, you mentioned certificates for every transaction. We have right now introduced in the 2.0 in the next version of our e-delivery specs, an option to change the certificate programmatically. So you send an e-delivery message and you can include your future certificate in that message. But I don't think that's really the direction that you want.
That would make it linkable.
But we have the ephemeral keys as well.
Yeah. So you need to build it in isolation every time. But I understand your suggestion, and I have some thinking about how to do it. But what I was more addressed is because all the presentations today assume something that I thought people would be considering obsolete, and that makes me very concerned. Because we are heavily centralizing control in the way that we are doing it. And we are not questioning the damages as a consequence of that. And for your delivery, you need to have thinking about rendezvous points where you don't know where this is going to end up, but you can only deliver it when someone approaches you to request it. Because you don't know which physical entity it is, if you get my point. But the one entity requesting the message can prove that they are the receiver of the message. Otherwise, if you know the endpoint identity, then you have transfer control into the delivery system.
That might be an interesting approach for addressability in the case of a delivery, because of course today delivery has to indicate a recipient. So if you suggest that this needs to be somehow set based on roles, not based on identity, that might be a direction of development.
Virtual one-time only delivery point, as an example, would take control out of the e-delivery system and put it up in the application or down at the edge, depending on how you look at it. So instead of having an e-delivery as a surveillance structure per se, you get an e-delivery that can take a message and store it until it's collected.
Yeah. Well, no, we have this option based on pull, but it's still addressed to a specific recipient who may come to pull it. So it's not always a push model. This push and pull is already there. But okay, I suggest, as I said, if you want to make a well-formed proposal, looking at our existing specifications, in some suggestions, or including some suggestions on how we could improve them, please do so. I would try to address maybe some of the other points, and thank you once again for your intervention in the chat. I see two questions. Do we still have time for explaining the relationship between the delivery and QERDS? So Vlad, if you think you can do that, and then we can move to the last question I see for now.
So we move to the very last topic before.
Yes, Nimesh.
Okay, good. Thanks.
I was telling yes, I can speak about this, and it's about QRDS and EERDS, the way they are defined by former EIDAS, current EUDI regulation. When it's come to ERDS, it's has its definition in the EIDAS regulation, and you can see this definition on the left side of the slide on the white side of the slide. And by looking at this definition, we can we judge that e-delivery it's in line with this with what's described in there, and it can be used for having this having e-delivery deployed in a C2 to C3 leg of a four-corner ERDS. I'm not maybe speaking about the C1, C2, because it might be that there is a customer, there is a citizen in there, and we mentioned that we need an intermediary system to be human user facing. So this is for ERDS. When we speak about QRDS and when EIDAS speaks about QRDS, it lists a list of requirements on top of the ERDS requirements. And out of these requirements, several are creating a challenge for e-delivery. We identified one even in the challenges slide, and this is the presence of the qualified timestamp in the signature. With the format of the signature we have today, we don't have this qualified timestamp in there. Still, what we can add to this is that we have ETSI that starting from VRDS in UDI derives the set of requirements for this QERDS systems. And by looking at these requirements and also by consulting directly with ETSI, we can say that delivery is compatible with the ETSI specification for VAS for building of the ERDS relay interface. This might sound complicated, but what it says in short is that e-delivery is suitable to be used as a interoperability protocol between QRDSPs, so between systems that provide QRDS. This could be at national, but even cross-border QRDSPs. So if you have a QRDSP in one country, it might very well work that you use e-delivery to connect it to a QRDSP in another member state. And to me, this is a valuable thing to have. The last point is that actually ETSI specifies two potential protocols as certified for this relay interface between QRDSPs, but with the EUDI, actually Commission has under public consultation that the registered email, that is the second, is the competing specification, would be removed as certified, and this will leave the ES4V only certified protocol for implementing this interface.
Vlad, I would briefly intervene here because this is not exactly accurate. It's not about certified or non-certified. It is presumed compliant versus you have to prove compliance. So perhaps it's the same thing for in some interpretations, but legally speaking, you can use at least that's the draft act. You can use any number of technical approaches, but some may have presumed compliance.
To prove they meet the requirements. With these two, you don't need to prove.
Yes, correct. But further approaches are allowed. That was the key.
Yes. This is out of this is already checked.
Thank you, Vlad. I believe if we still have final questions, we can still take them.
In the meantime, to the attendee who has been asking about the digital credential, we really do not know how to help you. This has no relationship to e-delivery, so I do not have a suggestion, I'm afraid.
I look at the link that was posted, and I think it might be linked to OTS, being credentials about studies, etc.
It seems to be about apprenticeships. We are not a specific or representing a specific policy domain. That's why, and also if this is in the context of a policy domain that uses e-delivery, then you can mention the policy domain, for instance, the once only technical system, if that's the case. But I don't see this being related to the once only technical system. If it's a policy domain that does not use e-delivery, we of course do not have the contact details for the thousands of policy domains that the European Commission is in charge of. So you would really have to find contact details separately from this webinar. I don't see any further questions in the chat. So Ines, maybe to you.
Thank you. Yes. So thanks again for everyone's participation. Just to reassure you that we will publish the slides, and we will also publish further resources and information about trust models in e-delivery. So you will be notified about this. In the meantime, you can go to our website and see what we have already there. So thanks a lot, and hope to see you in the next webinar.